Welcome to Brain Vision.
For this problem, you are going to want to use a ruler because they're having you place an object a distance of 20 centimeters in front of a lens, a convex lens of focal length 10 centimeters, and move that object at 5 centimeters, and then repeat this with a concave lens at 20 and 5 centimeters. So I'm going to draw a sketch of these, but again, you are going to want to do these to scale. So what that means is if I place my objects, so both of these at the very top are convex lenses with focal lengths of 10 centimeters. So I'm going to estimate my 10 centimeters to be out here for both of them. So focal is 10 centimeters. And my objects are going to be placed on the left. One of them is 20 centimeters, the other one is 5 centimeters. So for the one that is 5 centimeters, this is the distance of the object. You're going to actually want to measure this out using a ruler. And then the other one is going to be 20 centimeters. For me, that is already off my screen if I was to try to make this proportional. So I'm just going to kind of put it very far away. So then my object is going to, in this case, represent being represented by an arrow. So I'm going to draw an arrow in both situations. And then we're going to start off. Go ahead and make this really quick. We're going to start off by drawing a line parallel to the principal axis. So parallel, going until we hit that lens, and then going through my focal. And then our second one is going to go through the center of the lens and then straight through. So you can see how they're actually going to be intersected way out here. And then you can measure that distance. And that distance for the first one should be very, very close to about 20 centimeters. And then for the second one, you're going to want to draw it parallel to the principal axis and then through the focal. And then the other one is going to start at the top of the object and go through the center of the lens. You can see how they start to move away from each other. That means that this image is not going to be produced on the right side of the lens. It's actually going to be produced on the left side. So we're going to backtrace both of these rays. And you're going to see that my image is being produced where the two lines intersect. And then you can measure that distance, and that distance should be very close to about 10 centimeters. For the second one, my concave lenses always have negative focals. So instead of being a distance of 10 centimeters to the right of this, I'm going to draw them as the 10 centimeters to the left of this. So this is about 10 centimeters. You're going to want to measure that. This is 10 centimeters. 10 centimeters. And concave lenses all produce virtual images. So the first one, like I said before, is my screen's a little too small to show this to scale or in proportion to, but I'm going to draw it about twice as far away, which is a distance of 20 centimeters. And then my object for the second one is going to be at 5 centimeters. Starting at the very top, we're going to go through and draw it parallel to the principal axis, and then we're going to go through our focal. So for this one, we are going to backtrace it. And then these lenses, you can see that it's drawn above the lens. That's okay. You just want to imagine that you have this line going through the center of your lens, and we're going to draw it till we hit that point. And same idea. These are diverging lenses, which means the light's actually going to go away from the axis, the principal axis in the middle. And then the next line, starting at the top of the object, is going to go through the center of the lens, where the 2 points intersect is where my image is being produced. That distance we can measure to be 6.7 centimeters. The fact that we got a negative here just tells us that it's on the left side of the lens. And then the next one, starting at the very top, parallel, then through my focal, then back trace it, then through the center, and then back trace. Where the 2 points intersect is where my image is being produced. This distance is the distance of the image, which you should measure to be about 3.3 centimeters. Again, the more precise you are using a ruler and making all of your diagrams and making sure you're hitting right at the center of that lens and right through our focal and drawing straight lines at all these points, the more accurate your images are going to be. Now, for all of these images that are upright, all of these are virtual images. So upright images are all virtual images, and then when you have a inverted image, this is a real image, which means it can be projected onto a screen.